Okay, so today we're talking about gases and chemical reactions. So there's going to be some definitions and then everybody's favorite thing, math. So you're going to want to write all this down. In reactions involving gas, the amount of gas is normally specified in terms of its volume at a given pressure and temperature. Okay, so I'm going to read that again. In reactions involving gases, the amount of gas is normally specified in terms of its volume at a given pressure and temperature. So what that should say to all of you is we're still using this formula. Because if you look at it, you have pressure, temperature, and volume. So really what you're going to be calculating is moles. Alright, so I'm going to give you some examples. We're going to work through this. And this might make a little more sense. So write this down. Calculate the number of liters of gas that forms at a pressure equal to 1.0 atmospheres. Temperature equal to 273 kelvins, or STP, when 0.879 moles of calcium carbonate undergoes this reaction. Okay, so let me write the reaction, and then we're going to break down what this sentence is saying. It's an ugly T. Hang on. Okay, so let's write this. You have Ca CO3, and then this is going to be a solid. So when it breaks apart, usually when you put heat in it, you're going to have calcium oxide plus carbon dioxide gas. So what we're trying to calculate here is the number of liters of gas that forms at a pressure equal to 1.0 atmospheres, temperature equal to 273 kelvins, and then we're given a mole amount of a reactant of this. So we need to find the liters of gas that are created. So this is what the equation is going to look like. P times volume of CO2 equals the moles of CO2 times RT. And then R, as you know, is the universal gas constant. So R, we already know the value is 0.0821 liters times atmospheres over moles times Kelvin. So how do you think we're going to solve this? Alright, I'm going to let you pause and figure this out, and then I'm going to go ahead and solve it. So the volume of gas is usually, you're going to have to do a stoichiometric analysis of the problem, but if you look here, you don't really have to do that because it's 1, 1, and 1. So that means when you convert it to gas, 1 mole of CaCO3 times 1 mole CO2 over 1 mole CaCO3, these cancel and you're still left with 1 mole of carbon dioxide. So that's why you don't really have to worry about the stoichiometry in this problem, but you still have to calculate it. So since it's a 1-to-1 ratio, you can just plug in the number for NCO2 equals 0.879. So if you want me to do that, really just plug 0.879 over here. And then you're going to be left with sorry, I should have done that in the first place, but I kind of thought it was obvious. So your moles of carbon dioxide are 0.879 moles. All right. And then we've been given everything else in standard temperature and pressure. So that means P of CO2 equals 1.0 atmospheres. And then we have temperature of CO2 equals 273 kelvins. So really, all you have to do now is plug this into the equation. So let's do that. We have PV equals nRT. We'll label everything PV nRT. 1.0 atmospheres. Unknown 0.879 moles. CO2, just so you know what it is. 0.0821 liters times atmospheres over moles times Kelvin. And then you have 273 Kelvin. This problem is actually very easy compared to the homework you guys have been getting, but that means that this should be a very easy lesson for you guys. Alright, so let's plug this in and figure out what we get. So since we're trying to find volume, we just divide P out. I like setting up the equations beforehand because then I don't have to do it with the numbers. So that means V equals 0.879 mole times 0.0821 liters times atmospheres over mole times Kelvin times 273 kelvins divided by 1.0 atmospheres. So you don't have to really divide it by anything because it's going to come out to the same number. But you just look at what you have in terms of units and you cancel it out, and that's going to give you what you need. So let's plug this into the calculator and see what we get. So you have bad form, let's do parentheses, 0.879 times 0.0821 times 273. And then if you divide it by 1, that's going to mean that your volume is 19.7 liters. So that one was super simple. It was just kind of to break the ice, let you know how to do this. The next one, I believe, is going to have some stoichiometry in there. So I'm going to write that down. If you need to go back and copy everything, just go back and pause the video and copy it. Alright, let me see what I'm doing on time. Alright, good. Trying to keep these at about 30 minutes because if I go any longer, I'm going to start losing you guys because I know these are not the most interesting things, but anyways. So methanol, which is CH3OH, can be synthesized. And then synthesized, all that means is made by humans. Or whatever. Not even made by humans, just made or created. Usually we say synthesized when we're talking about inside a lab or something, or in a factory. It's synthesized. Anyways, it's not one of those scary words like GMOs. It's all it means. Anyways, methanol can be synthesized by the following reaction. So, CO2, I think. Oh, no, wait. Carbon monoxide. Sorry, my handwriting was pretty atrocious on these notes, so it's hard to read. CO gas plus 2H2 and that's gas is equal to CH3OH. Alright, so this would be what we're trying to figure out. Or this is the reaction. And then this would be a gas. So let's write the question down. What volume in liters of H2 gas at 355 kelvins and 0.971 atmospheres is needed to get 35.7 grams of CH3OH. So I'm going to give you the molar mass for CH3OH. So let's figure this out. We have 12, 4, 16, that's 20, 32. So 12 plus 4 is 16, plus 16 is 32. So we're going to have to do some stoichiometry here. Actually, we just need unit conversions for right now. Anyways, so we have 35.7 grams times 1 mole over 32 grams. So we need to find out how many moles of gas we need to make this many grams. So let's do 35.7 divided by 32. And then that's going to give you about we'll just do 1.12. So that's 1.12 moles of H2. Or of CH3OH. So we have to figure out how many moles of hydrogen were needed to create this. Alright, so let's figure this out. We have 1.12 moles CH3OH times 2 moles H2 divided by 1 mole CH3OH. So 1.12 times 2 is 2.24 moles H2. So this is how many moles of hydrogen gas that we need. So the volume in liters at this temperature and this pressure is needed to get this many grams. So again, PV equals nRT. And this is for H2. I'm not writing all the little subscripts because it gets kind of confusing. So we have 0, divide the P out. So we have V equals nRT over P. So we're going to do volume equals 2.24 mole of H2 times 0.0821 liters times atmospheres over mole times Kelvin, and then that's at a temperature of 355 kelvins. And we divide it by the pressure, so that's 0.971 atmospheres, I believe. Let me double check. Yeah, that's right. Okay, so now we just have to plug this into the calculator, and it's going to tell us how many liters of hydrogen gas are necessary to do this reaction. So let's do this. 2.24 times 0.0821 times 355 divided by 0.971. So that means you're going to need 67.24. So volume equals 67.24 liters of H2. And then that's in gases, or gas. So you're going to need this much to make just 35 grams at this pressure and this temperature. Okay, so I have one more problem that we're going to go over. So let me copy. I think I already did. Yeah, here we go. I'll give you a second. Pause the video if you want to write this down. Anyways, so I'm going to go now. So we'll rewrite the reaction. We have 2NaN3 breaks up into 2 sodium metals plus 3 nitrogen gas. Wow, why am I doing that? Okay. This reaction is used to inflate the airbags that cushion passengers during automobile collisions. The reaction is initiated in airbags by an electrical impulse and results in the rapid evolution of gas. That means that lots of gas gets made super quickly. If the nitrogen gas that results from the decomposition of a 5-gram sample of sodium amide, or azide, could be collected by displacing water from an inverted flask, as in, you guys don't know because I didn't post the figure, what volume of gas would be produced at 21 degrees Celsius in this pressure? So let's figure this out, because I actually didn't do this one ahead of time. Well, actually, I didn't do any of these ahead of time. So, all right, first off, we have PV equals nRT. We have our stoichiometric ratio. So first, we're trying to figure out what volume of gas would be produced. So this is going to be in units of nitrogen gas. So you divide by P. So you have 5 grams of sodium azide. So let's figure out what the actual molecular mass is, because we weren't given that. That's 22.99 grams per mole. And then that's 42 grams per mole, because it's 14 times 3. So you just add these up and you're at about 64.99. Yeah. 64.99 grams per mole. So now we have to figure out how many moles we originally had before we do any stoichiometry. So you have 5.00 grams NaN3. Oh, sorry, I had to crack my knuckles. All right. Times 1 mole over 64.99 grams of sodium azide. So these are going to cancel, and you're in moles of sodium azide now. So let's use the calculator. You have 5 divided by 64.99. So this gives you 0.7, we'll just put 77. Make sure. Oh, 0.0. Wow. So we have 0.077 moles of sodium azide. So right here, that's the first thing we needed. So now we have to convert this to this using our stoichiometric ratios. So that's a 2 to 3 ratio. You have 0.077 moles of sodium azide times 3 moles of nitrogen gas divided by 2 moles we have 2 moles of sodium azide. So let's plug this in the calculator and see what we get. So that means we're going to make a total of 0.1155 moles of nitrogen gas. All right. Now, so now we have to convert 21 degrees Celsius to kelvins. It's easy. Add 273 to it, or 273.15 if that's what you want. Hang on one second. All right, so that means we have 294 kelvins for the temperature. And then we have 762 millimeters of mercury times 1 atmosphere divided by 760 millimeters of mercury. This is going to be like essentially 1, but just to be sure. Yeah, 1.00. So we're just going to leave this at 1 atmosphere because it's not going to throw it off by that much. It's in the thousandth category. So the pressure is 1 atmosphere. So now we have everything that we need. We just have to plug it in. So N, T, and then this is P. So remember, V equals nRT over P. So that means V equals, let me copy that number, 0.1155 mole of N2 times 0.0821 liters times atmospheres over moles times Kelvin times, and then the temperature was 294 kelvins, and then the pressure was essentially 1, so 1 atmosphere. So let's go ahead and cancel our units that we have. Moles cancels, liters does not cancel, atmospheres cancels, and kelvins cancels because we're trying to find volume. So the question is, what volume of gas would be produced under these conditions? This is the equation you're going to use right here. So let's plug this into the calculator. 0.1155 times 0.0821 times 294, and then divided by 1. So that means you're going to make a total of about 2.79 liters of nitrogen gas. Let me see what I'm doing on time. Alright, so that's pretty much it for this. The only thing you should be aware of is practice your stoichiometry. Practice, practice, practice. If you don't remember how to do this, I suggest you go back and learn how to do it. We went over this in detail a while ago, but you need to know how to do all of what I just did. Conversions, molar mass, and then really all you're doing is you're thinking about what the question is asking you and plugging it back in an equation. So if you have any questions on this one, make sure you go to my office hours, email me, get in contact with me, because I don't know if you guys are getting this. I'm just assuming you are because I don't have many people coming to my office hours. Anyways, this lesson, and then we have a few more, but you're going to be having a test, probably not next week. You have a quiz this upcoming week, or this week you have a quiz. Sorry, I'm recording this a week before. You have a quiz this week on ideal gases and your gas laws. You're probably going to have a test next week dealing with the same concepts. And then we don't have much more in this unit, and then we're going to move on to acids and bases and start studying. Once we finish that unit, we'll start studying for your final. All right, so if you have any questions, please come to my office hours or email me.